Module 6, Section 4.5, Inverse of a square matrix. Objectives: understand identity matrix for multiplication. Objective 2, find the inverse of a square matrix. And Objective 3, calculate inverse of a square matrix using calculator. Identity matrix for multiplication. A matrix is called square matrix if it has the same number of rows and columns. All square matrices of order n have an identity element for multiplication. The identity element for multiplication for the set of all square matrices of order n is the square matrix of order n denoted by I with ones along the principal diagonal and zeros elsewhere. Here are some examples. We have a 2 by 2 identity matrix which is written as matrix 1 0 0 1, and we have a 3 by 3 identity matrix which is 1 0 0 0 1 0 0 0 1. This is what you call the principal diagonal. If M is a square matrix of order n and I is the identity matrix of the same order, then I multiplied with M and M multiplied with I both are equal to M. In symbols, if we have a 3 by 3 matrix, and if we multiply with a 3 by 3 identity matrix, we will get the same matrix back. So let's verify this. We take the first row, multiply with the first column. So what we are going to get is A11 multiplied with 1 plus A12 multiplied with 0 plus A13 multiplied with 0. That comes out to be A11. Then repeat with column 2. A11 multiplied with 0, A12 multiplied with 1, A13 multiplied with 0. So that will produce A12. Then column 3. We again get A11 times 0 plus A12 times 0 plus A13 times 1. We'll get A13. So we can verify the other entries too. Show that the product of a matrix A with an identity matrix is equal to A. So in order to verify this, you take the first row, multiply with the first column. So let's calculate few of this. 3 times 1 plus negative 1 times 0 plus 4 times 0. That is the product of the first row with the first column. So this calculates to be 3, which is this number up here. That is verified. Go to column 2. 3 times 0 plus negative 1 times 1 plus 4 times 0. So that calculates to be negative 1. Column 3. 3 times 0, negative 1 times 0 plus 4 times 1. So that verifies 4. Now we need to take row 2 and multiply with each of the columns, getting the second row of the product. Row 3 and multiply with each of the columns to get the third row of the product. So we can verify this. Finding the inverse of a square matrix. Some, not all square matrices have matrix inverses. If the inverse of a matrix M exists, we shall call it M inverse, or written as M to the power negative 1. So M inverse is a matrix which you can multiply M from the left as well as from the right, getting the identity matrix of the same size. Notice that I is the identity matrix. We call M inverse to be the multiplicative inverse of M. If the inverse doesn't exist, we call that matrix to be a singular matrix. Here is an example. Examine the product of the two matrices to determine if each is the inverse of the other. So here we have a 2 by 2 matrix with another 2 by 2 matrix, getting the product to be another 2 by 2. Let's calculate this. If I take the first row, multiply with the first column, I'm going to get 2 times 2 plus 3 times negative 1. So that comes out to be 1. Go to the second column, first row. So that will be 2 times negative 3 plus 3 times positive 2 becomes 0. Move to the second row. Second row with first column. 1 times 2, 2 times negative 1. That will be 0. Second row with second column. So that produces 1. So this is our I2 identity matrix of size 2. If we calculate this in the opposite order, we get the same value. If we calculate this product in the opposite order, we will again get the identity matrix of size 2. So the answer to the second question will be yes. Here is a procedure to find the inverse of a square matrix. To find the inverse of a square matrix M, first to form the augmented matrix M/I. Here this symbol is a vertical line that separates the two matrices M and the identity matrix. If M/I is transformed by row operations into I/B, then the resulting matrix B will be the inverse of M, written as M inverse. However, if one or more rows to the left of the vertical line contains all zeros, then M inverse does not exist. An augmented matrix is transformed into a row equivalent matrix by performing any of the following 3 row operations. 1. 2 rows are interchanged. So this symbol means the ith row and the jth row are interchanged. Second row operation. A row is multiplied by a non-zero constant. So the ith row is multiplied with k and it replaces the ith row. Third row operation. A constant multiple of one row is added to another row. So here the jth row is multiplied with k and added to the ith row, and that way the ith row is replaced. K rj plus ri replaces ri. This example illustrates how we can find the inverse of a matrix A using the row operations. So we create the augmented matrix A/I. A is of size 3, so we need to have an identity matrix of the same size, 3 by 3 identity matrix, which is up here. Our goal is to create an identity matrix on the left. So in order to do that, we need to do the row operations. So the first row operation can be R2 minus 2R1 replacing R2. So notice this element here in the second row, we have a 2. We need to get 0 there. So you multiply the first row by negative 2 and add to this. That is what this R2 minus 2R1 means. So we get a 0. And every other location in the second row is also changing. So for example, this 3 is obtained as 1 here plus negative 2 times row 1. Row 1 entry is negative 1. So we get 3. Likewise, 2 plus negative 2 times 3 will make negative 4. That is the next entry here. So that is the way you calculate the remaining entries of second row. Now in order to get 0 in the first column, third row location, we need to have row 3 plus 2R1. So that will put a 0 here. Calculate the rest of the row using the same rule. We get the first column looking like 1 0 0, which is part of the identity matrix. Now we need to have the 2 2 entry to get 1. That is part of the main diagonal here. So to get 1 there, I need to multiply the second row by 1 by 3. That is this operation here. So we get this 1. Then I need to make 0 in the remaining locations in the second column. So we need to choose the right row operations. So to get 0 in this location, I need to get row 1 plus row 2. That means the row 1 is changed as row 1 plus row 2. So we get 0 here. We have to calculate the remaining entries also. So this is calculated. This entry is calculated using the same rule. Now I need to get 0 in the third row second column position. So that will be -4. So we need to get 0 by adding a +4. So -4 plus 4 times row 2 entry is 1. That is how I get 0 in that location. So which is this 0 here. And then calculate the remaining entries of that row. So notice that now we have the first and the second column identical to that of a identity matrix. So now we need to go to the next pivot entry, which is the 3 entry here. It is not 1, so I need to make it 1. So 5 by 3. So if I multiply the third row with the 3 by 5, I will get 1 there. So make that 1. Then using this 1, I can make zeros in the remaining positions of that column. So we have 2 row operations to do that. So this row operation will put 0 there, and this row operation will put 0 there. Second row plus 4 by 3 times R3 is replacing row 2. So notice that the other entries will be changing using the same rule, and that makes identity to the left of the vertical line. 1 0 0 0 1 0 0 0 1. This is our identity matrix. So according to our definition, whatever we are getting here will be the inverse of A. So this is our A inverse. A sequence of row operations converting the augmented matrix A/I into I/A inverse. We can use the calculator to compute the inverse efficiently, and I'm going to demonstrate that here. We need to find the inverse of a 3 by 3 matrix. So let's call this matrix to be again A. First we need to edit the matrix. So I'll go to second matrix menu, edit the matrix A, which is a square matrix of size 3 by 3, entries, once we finish editing, go to the home screen, and then we are trying to find the inverse by calling the matrix name, which is A, and hitting the inverse key, which is written as x to the power -1. So if you press enter, we will get the inverse. It's in decimal form, and if you want to convert to fractions, we can go to the convert to fractions, enter.